Network topologies. What is a network topology? A network topology is the physical and logical arrangement of nodes and connections in a network. Nodes usually include devices such as switches, routers, and software with switch and router features. Topology: bus, ring, star, mesh, hybrid. Bus topology. Bus topology is a type of network topology in which all devices are connected to a single cable called a bus. This cable serves as a shared communication medium, allowing all devices on the network to receive the same signal simultaneously. One long cable acts as a backbone to link all the devices in a network. Advantages: cost-effective, uses a single cable for data transmission, which is cheaper than other topologies. Easy to install, adding or removing devices is straightforward. Network scalability can be extended by joining additional cables. High-speed data transfer, no intermediary devices between the nodes. Disadvantages: single point of failure, if the backbone cable fails, the entire network goes down. Low security, all nodes can hear what data is transmitted to other nodes. Reduced signal strength, signal quality can degrade as more devices are added. Slower network, adding new devices can slow down the network. Where we use educational settings, bus topology is a practical way to teach basic networking concepts. Industrial control systems, bus topology is used to connect sensors, actuators, and controllers in industrial control systems. Building automation systems, bus topology is used in building automation systems. Small networks, bus topology is often used in small to medium-sized local area networks, LANs, for home or office use. Star topology. A star topology is a type of network topology in which all the devices or nodes are physically connected to a central node such as a router, switch, or hub. The central node, hub, acts as a server and the connecting nodes act as clients. A star network is a local area network, LAN, topology. Advantages: centralized control, the entire network can be managed from a single location. High reliability, star topologies are considered more reliable than other network structures, especially when used with quality hardware. High security, data is only accessible by other nodes with permission from the central device. Cost-effective, star topologies are a cost-effective solution for enabling data transfer between numerous wireless sensors. Disadvantages: cost, star networks are expensive to install and maintain because they require a lot of cable and extra hardware, such as switches or hubs. Central hub failure, if the central hub or switch fails, the entire network will be inoperable. Network performance, the network's performance depends on the central device's capabilities and capacity. A limited hub can slow down the network. Security, unauthorized access to the central hub or switch can compromise the entire network. Where we use bank networks, star topology can be used in bank networks so that a compromise of one branch doesn't immediately compromise a second branch. Energy management, star topology can be used to monitor and control devices like solar panels, power generators, and energy storage systems. Computer networks, star topology is a common choice for modern computer networks because it allows for efficient and reliable connections between multiple machines. Ring topology. Ring topology is a type of network configuration where devices are connected in a circular manner, forming a closed loop. In this setup, each device is connected to exactly two other devices, creating a continuous pathway for data transmission. Each device has a dedicated point-to-point connection with only the two devices on either side of it. Advantages: data transfer, ring topology networks have high data transfer rates and are efficient. Data packets are transmitted in one direction, which reduces the Risk of collisions and interference. Reliability. Ring topology networks are more reliable than bus topologies because they don't have a single point of failure. Scalability. It's easy to add workstations to a ring topology network without affecting performance. Equal access. All devices in a ring topology network have equal access to resources and bandwidth. Disadvantages. Single point of failure. If a node fails, the network is broken and data transmission stops. Bandwidth efficiency. Ring topology has lower bandwidth efficiency than other topologies. Network disruption. Adding or removing nodes can disrupt network activity. Cost. Ring topology is more expensive than simpler topologies like bus. Where we use local area networks. LANs. Ring topology is often used in LANs to provide high reliability and multiple paths for data transmission. Industrial control systems. Devices are interconnected in a ring to monitor and control processes. Telecommunications networks. Ring topology is used to transmit data reliably and efficiently. Banking systems and stock exchanges. These industries require uninterrupted access to network resources and prioritize equal access to data. Mesh topology. Mesh topology is a network configuration where every device is interconnected with every other device, providing multiple routes for data to travel. The nodes are connected to each other completely via a dedicated link during which information travels from nodes to nodes. If a mesh network has n nodes, then there are n(1)(2) links. Every device has a dedicated point-to-point link to every other device. Advantages. Speed. Mesh networks provide faster data transfer speeds because of multiple paths and shorter distances. Security. Mesh topology can improve network security by encrypting data and routing it through secure paths. Ease of use. Adding new devices is easy because they only need to connect to nearby nodes. Reliability. Mesh topology is more reliable than routers and extenders because it provides redundancy and fault tolerance. If one device fails, the network can still operate because data can be rerouted through other nodes. Disadvantages. Setting up a mesh network can be complex and time-consuming. Troubleshooting can be difficult because data can take multiple paths. Maintenance. The many connections in a mesh network require a lot of maintenance. Power. Mesh topology requires a lot of power because all nodes need to be active at all times. Hybrid topology. It consists of two or more other network topologies: mesh, star, bus and ring. Advantages. Flexibility and scalability. You can integrate different types of topologies based on the specific needs of different departments or network segments. Optimized performance. Each segment can be designed using the topology best suited for its needs, maximizing the overall network performance. Fault tolerance. Failure in one segment does not affect other segments. For example, a fault in the bus topology segment won't impact the star topology segment. Efficient resource utilization. Resources can be allocated effectively to different segments based on their requirements, avoiding overloading or underutilization. Cost effectiveness. It allows a cost-efficient mix of high-performance segments and simpler, more affordable setups. Disadvantages. High cost. Complex design and management. Difficult troubleshooting. Increased hardware requirements. Scalability limitations. Where we use building monitoring and control. Mesh networks can be used to monitor and control lights, HVAC, and other functions in large office buildings, hotels, and hospitals. Industrial monitoring and control. Mesh networks can provide information on procedures and manufacturing techniques. Medical monitoring. Mesh networks can help patient surveillance and expand capacity. Thank you.